The question is this way: the number of electrons involved in reduction of potassium permanganate to manganese dioxide in weakly basic medium. So how do we go about with this? MnO4 minus in weakly basic or neutral medium, it will get reduced to MnO2, producing OH minus ions. Upon balancing, the reaction goes this way. When we look at the charges on the reactant side, it is -1, whereas on the product side, it is -4. To bring down and equate the charges to lower value, to get -4, we are supposed to add 3 minus here in the form of 3 electrons. So our answer will be 3 electrons. The number of electrons involved in reduction of MnO4 minus to MnO2. Here in MnO4 minus, permanganate lies in +7, whereas in MnO2 it is in +4. For the reduction of MnO4 minus to MnO2, it requires 3 electrons, meaning it has to gain 3 electrons in order to get reduced to MnO2. So our answer will be 3 electrons here. The question is like that: the disproportionation of MnO4 2 minus in acidic medium will result to 2 manganese compounds. It will result to 2 manganese compounds, A and B. If the oxidation state of manganese in B is smaller than A, then the spin magnetic moment value of B is equal to how much? Isn't it? So now what we have to do, we know that MnO4 2 minus manganate ion in acidic medium will disproportionate into formation of MnO4 minus permanganate ion and MnO2, which are A and B respectively. In MnO4 2 minus, manganese is in +7 oxidation state, whereas here it is +4 oxidation state, which is lower than manganate. Now the question is, then the spin only magnetic moment value of B is equal to how much? The spin only magnetic, that is mu value, is equal to how much? So here manganese is in +4 oxidation state. The valence electrons of manganese is 7, lost 4 electrons. It has 3 unpaired electrons. So by using spin only magnetic moment root n into n plus 2 Bohr magneton, where n is equal to number of unpaired electrons. So let us substitute the unpaired electrons here. 3 into 3 plus 2, which is nothing but root 15, whose value is nearly 3.87 Bohr magneton. So the answer will be 3.87 Bohr magnetons. The question is, H2S reacts, 5 moles of H2S reacts completely with acidified potassium permanganate solution. The number of moles of water produced is X and number of moles of electrons involved is Y. The value of XY we are supposed to know. So the balanced equation is like that, where 2 MnO4 minus plus 5 H2S in acid medium will give 2 Mn2 plus 5S plus 8 H2O. So 5 moles of H2S is producing 8 moles of water. That is X. So X value is equal to 8. We have found the X value. How about B value? Y value here. H2S to S here. So H2S, when we write the ionic equation, H2S 1 sulfur and 2 H plus ion. Here the oxidation state is 0, whereas here it is +2. To bring down to 0, we will add -2, meaning in the form of 2 electrons here. From this equation we understood 1 mole of H2S requires 2 electrons, 2 moles of electrons. So 5 moles of H2S requires 2 into 5 moles of electron, that is equal to 10, which is nothing but Y. So here Y is 10. And our question is, what is the value of X plus Y? That is equal to 8 plus 10, that is equal to 18. So our answer will be 18 here. The question is, KMnO4 is titrated with ferrous ammonium oxalate hexahydrate, which is nothing but molar salt, in the presence of dilute sulfuric acid. The number of water molecules produced for 2 molecules of permanganate is. This we can solve in 2 ways. First one is, the simplest way is 2 molecules. First we will know how permanganate will get reduced. In acid medium, MnO4 minus in acid medium get reduced to Mn2 plus. When we balance the atoms here, there are 4 oxygen here. I will add 4 H2O molecules here, and 4 2s are 8 H plus here. Meaning 1 mole of permanganate is producing 4 moles of water molecule here. If it is 2 moles of permanganate, then water molecules will be 8. So the answer should be 8 here. Now how do we solve the other way? Balanced equation, that is 2 moles of KMnO4 on reacting with 10 moles of FAS, that is FeSO4 NH4 twice SO4 6H2O plus 8H2SO4 gives rise to K2SO4 plus 2MnSO4 plus 5Fe2SO4 thrice plus 10 NH4 twice SO4 plus 68 H2O. Meaning here 2 moles of permanganate is producing 68 moles of water molecule. Meaning if you ignore this 10 into 6, 60 moles of, meaning 60 water molecules present in FAS. If you minus from this 68, then you will be left over with 8 molecules of water. As we are strictly talking about the redox reaction, we will bother about how permanganate will produce water molecules, how many moles. Therefore, the answer should be 8 here. So, our answer is 8. The question is this way. Acidified solution of potassium chromate with an equal volume of amyl alcohol and shaken after the addition of 1 ml of 3% hydrogen peroxide, a blue layer was obtained. The blue color is due to the formation of chromium 6 compound X. What is the number of oxygen atom bonded to chromium through only single bonds? The question is like that. So potassium chromate, that is K2CrO4, reacts with amyl chloride, amyl alcohol. Amyl alcohol is nothing but pentanol, 5 carbon atom alcohol, pentanol, that is C5H11OH. When it reacts with 1 ml of 3% hydrogen peroxide, 1 ml of 3% hydrogen peroxide, a blue alcohol layer was obtained. The blue color is due to formation of chromium 6 compound. Chromate ion in the presence of alcohol and hydrogen peroxide. Here amyl alcohol acts as a solvent. In the presence of this solvent, chromate will form chromium pentoxide. This chromium pentoxide is blue in color. And this is unstable compound. It is a peroxo compound. Peroxo compound. And this is the answer. This chromium pentoxide will have a butterfly structure. It is this way. It will have butterfly structure like Cr will bond with one oxygen with double bond and 4 oxygen will bond to chromium with single bonds like that, and these oxygens involve in peroxide bond this way. So we call it as peroxide here, and here each chromium is linked with 1, 2, 3, 4 oxygen by single bonds here. So the question is only single bonds. So our answer will be 4. This is the answer.